Hello friends, welcome to Engineering Funda family. In this video, I'm going to explain you link state routing algorithm. And to understand this algorithm, let me show you how many things that I'm going to cover in this video. See, first I'll explain you how many basics are there with link state routing algorithm. After that, I'll explain you how working is there with this algorithm. After that, I'll explain you few essential key parameters like what is sequence number in link state routing algorithm and what is the need of this. After that, I'll explain you what is age and TTL in link state routing algorithm. The reason is in some books I have seen age and TTL both are considered as same parameters. Like in Tenenbaum, I have seen Professor Tenenbaum have considered both has similar parameter, but both are having differences. So I'll explain you that differences with practical examples. So let us try to understand first how many basics are there with link state routing algorithm. Link state routing algorithm that is broadly used in computer network. You can say in 2023 even majority of routing that happens with the use of this algorithm only. See, this algorithm that is implemented using OSPF protocol. So this OSPF, open shortest path first protocol, that uses this algorithm only. There are some other protocols even that is using this algorithm to have shortest path identification, but widely used protocol that is OSPF only right now in 2023, and this protocol uses link state routing algorithm. First of all, you need to understand what is the meaning of link state. See, in my last video, I have explained you distance vector algorithm. So in that, if you observe, I have considered this example, right? In that, if you observe router A, router B, router C, router D, that is connected via link over here. And these links are having magnitude 3, 2, 23, 5, right? So this magnitude of link, that is referred as link state. This magnitude of link, that is referred as link state. You can say distance, right? So here, link state routing algorithm that starts from identification of link state. How that link state determination happens? That determination is done by routers using hello packets. So what router does is, router will be sending hello packets to their neighbor. Like you see here, we are having router A, B, C, D. So this router will forward hello packets to their neighbor router. Like A can forward hello packets to B, A can forward hello packet to C, and it will take acknowledgement, and based on acknowledgement, it will identify what is the distance magnitude. So here in between A and B, distance is 3, in between A and C, distance is 23. So based on hello packets, it will identify distance magnitude, right? Once link state is there with routers, all the routers will share their link states by flooding link state packets. So first link state identification happens. After that, all the routers will flood their link state in entire network. Practically, if I tell you right now in entire globe, there are millions of routers. So first all the routers will identify their link state, means with how many links they are connected. For that it will give distance magnitude, right? And once all the routers are having their link state with each other, what they do is they run algorithm. You see, first they will be identifying link state. After that, they will be flooding their link state on network. And after that, shortest path determination that will happen with the use of Dijkstra's algorithm. So first of all, you see what is happening. Router A, router B, router C, router D. These four routers are sharing their link state to each other. Once all the link states are available with all the routers, they will be running Dijkstra's algorithm inside router. And based on that algorithm, it will identify what is the shortest path, right? So here, see, in this routing algorithm, first identification of link state will happen, then routers will share their link state by flooding, and once all the link states are available with routers, router will determine shortest path with the use of the Dijkstra's algorithm. See, with the use of link state routing algorithm, Routers will route the frames with the global knowledge of computer networks. This statement that I have written specially to make sure you should understand what is the meaning of global knowledge of computer network. See, in computer network, there will be millions of routers, right? And here, see, all the routers are having knowledge about what are the link state of other routers. And based on the knowledge of link state of other routers, Dijkstrata algorithm is identifying shortest path, right? Previously, when we have seen distance vector algorithm, so in that, those routers were having local knowledge only. They were been having knowledge of their neighbor routers only, or you can say small network only, right? But in link state routing algorithm, here all the routers are having global knowledge of other routers, and they are having that knowledge. Based on that only, they are identifying shortest path with the use of Dijkstrata algorithm. So in data structure, I'll explain you how Dijkstrata algorithm is there. Right now, just consider shortest path determination that happens via Dijkstrata algorithm. Now I'm going to explain you working of this link state routing algorithm. So to understand working, as I have told you, all the routers will identify their link state first, and that is done with the use of hello packets. So router A will send hello packets to B over here and to C over here, and based on acknowledgement, it will identify distance. So from router A to B, distance is 3, right? And from router A to C, distance is 23. That determination that happens via hello packets. Router B will send hello packets to A and C. So with A, distance is 3, and with C, distance is 2. Router C will forward hello packets to A, B and D. So A, B and D distance that will come based on acknowledgement. So with A it is 23, with B it is 2, and with D it is 5. Router D is connected with C only, so it can send hello packet to C only, right? And it will identify distance magnitude, that is 5. So that is how link state determination that is done by all the routers. After that, all the routers will forward their link state to each other by simply flooding packets. In packets, these are the information that will be given. But if they are sending packets like this, then there can be issue of flooding. Flooding means there can be congestion in the network. So to resolve issues of congestion in the network, there are some essential parameters like sequence number that is added with this link state. Let me show you how. So with link state of router, sequence number is added, right? So here we are having 4 routers. So for that we have seen how link state is there, right? Along with that, we are adding sequence number. Now what is the need of sequence number? See, link state information that is dynamic. It will change with respect to time with changes in topology or due to some network issue. For example, if I talk about router A connection with B, what if this link is getting down? Then obviously link state of router A will change. For example, as if I say router A itself goes down, then also link state of this network will change. Link state of B with respect to A will change. Link state of C with respect to A will change. So here link state information of entire computer network that is dynamic, that will change with respect to time, right? And as it changes with respect to time, there has to have sequence number. Let me tell you how. See here, for example, right now with router B, link state information of A, C and D that is available. You can see over here in table. So with router B, node A link state, node C link state and node D link state is available. With that, here I am mentioning sequence number. Let us say this is 15, 20 and 18. Now see what is happening is, let us say here router B that is also connected with some network, right? And see via some long distance, let us say router A's link state information that comes over here, let us say that information is having sequence number that is 10. Right now with router B, with router B, sequence number 15 that is available. But because of so much long distance, again older packet that is coming over here with sequence number 10 with router B. What router B will do? Router B will see I'm having sequence number 15 and this is older one, so it will discard this. The reason is, you see, continuously all the routers are sharing their link state. So it is but obvious after some time you may get older packet again, and again if you re-forward that, then what will happen? This entire computer network that will get too much congested, right? So here, as if you have sequence number, then all you can do is you can simply discard older packets, right? So sequence number that is added over here to discard older packets, and that will reduce congestion in entire computer network, right? So sequence number also reduces the effect of flooding in computer network, but still there are some issues, and those issues that we can resolve with the use of TTL field and age field. Let me show you how. Before I start with explanation of age and TTL field, let me tell you there are some confusions which I have seen in books. I have seen in books they are considering age and TTL as same field. Let me tell you, both are very different things. See, TTL, that we use it to avoid infinite loops. For example, as if I say here we are having TTL field that is there with this link state. Now link state that is getting forwarded in computer network, and as if there are some infinite loops, then you cannot avoid without TTL. Why? The reason is TTL field that will get decremented after one hop. Like when this packet is getting routed from A to B, it will decrement TTL by 1. When B is routing it to C, it will decrement it by 1. Again C is routing it to A, again it will get decrement by 1. So after some time TTL will get 0, and as if it is getting 0, simply router will drop that packet. So with the use of TTL, we are avoiding infinite loops. I have seen some questions like, what is the meaning of transient looping? See, transient looping means temporary looping. If you have TTL field, for example, if I say TTL field that is equals to 18, right? So it is possible this frame may have 6 time loop over here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 6 time loops that is possible over here, right? So temporary looping will happen. It will not be infinite loops, right? Or you can say non-persistent loop, means it will not persist. After some time it will get vanished, right? So TTL field that is used over here to avoid infinite loops, and this TTL field that is added along with link state information. So this packet of link state that is having TTL field. While when we talk about age, then age is there in the table of router. Let me explain you by one practical example. You see, this router is having link state information of A, C, D. So with A, there will be sequence number that is 50. With C, there will be sequence number which is 20. With D, there is a sequence number that is 18. And with this sequence number, there is finite age, or you can say timer, or you can say lifetime. Let us say this age is 60 minutes, right? So with respect to time, timer will run over here and this time will decrement, right? So after some time, this entries that will become invalid. So again, router B will have to update these entries, right, with the use of link state information. Now you might be thinking like, why we need to have updation after some time? The reason is, what will happen is, after some time, what if some routers are getting restarted? Let me take one example. For example, right now with router B, sequence number is 15 for node A. Now let us say router A is getting restarted. As if A is getting restarted, A will be forwarding link state information with one packet. Let us say with this packet, as router A is getting restarted, it is starting from sequence number 0. And as if it is starting from sequence number 0, router B will say what? It will say, I am having updated data that is having sequence number 15 and you are sending me sequence number 0. So this is false information. So I cannot take this and it will drop this packet. Right. So even router A is forwarding updated data right now. Router B will simply ignore this. Why? The reason is router A will start from sequence number 0. It will not start from sequence number 15 onwards. Right. So as router A is getting restarted, updated data that is not getting reached over here. And to avoid those issues, there is age or lifetime of all these entries. Let me give you one more practical example. For example, as if I say you are available over here at your home. Let us say this is your home, right? And here you see two routers are there. Here we are having two routers and communication is happening like this, right? And here you see some connections are there with routers. Now, for example, as if I say this router, let us say this router R1 is giving path to your home like this, right? Then what will happen as if this router goes down? What will happen as if this router goes down? As if this router goes down, then what will happen? See, right now with this router, information is like entries are there as per this route only. And this router goes down and still this router is sending link state information. This router is sending link state information with 0. And this router is not updating it. It is saying this is invalid. And because of that, even by this router, services are possible, right? Even by this router, services are possible. Service will not be granted to you because of these entries, right? So here we are having age of all the entries, and after some time those entries will become invalid. So again router B will update all these entries. Otherwise what will happen, like for undefined time period your home will be disconnected from internet, right? So that's why this age is there. That's why this age is there in implementation along with link state routing algorithm. See, this is just a basic overview that I'm giving you about link state routing algorithm. Otherwise, along with this table, there are so many other entries even, like what is acknowledgement number, right? So some more details are available, but you need to understand some basics. And as if you want to become network engineer, you should go in more detail. That will give you more clarity regarding how exactly everything is happening. I hope I have given you sufficient information. Still, if anything that you would like to share, please note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.